Hello everyone and welcome to our next video on Simple AI with Python and Colab. And today we do the most interesting thing. We'll try to count how many people live around us, for instance in 1 kilometer range. How can you do this in ordinary life? You can go into the street, count all the buildings around you, estimate approximate number of households and multiply it by an average number of members of family or household, but it's all a long time. But we can do this in 1 minute, not standing up from our chair. Thanks to Columbia University's Center for Earth Science and Amazon Web Services and Facebook, we have HRSL. And this is an open dataset where official census data are statistically distributed over the living buildings all over the planet on the high-resolution satellite images. And precision is 1 arcsecond, which means that we know how many people live in each 30 by 30 meters box all around the planet Earth. Isn't it magic? Okay, so what we'll do is we'll try to get geoposition from our address, and then we will download the relevant HRSL file. We will opt for CSV, though there are also geotiffs, and we will count people from all the boxes 30 by 30 meters that fall under our target's 1 kilometer area. Okay, so first we will install OpenStreetMaps. This is a module to get geoposition from our address and to plot a map. Well, it is installing. Next we will import pandas, as we'll use the pandas data frame to query CSV tabular data. And let's restart runtime. Yes, and we import OSMNX module itself, and we'll use NumPy, and we'll need requests to download HRSL file for the specific country from URL. So next we give a point of our address. Let it be one of European capitals, so that very certainly discovered by HRSL. Let it be Budapest, Hungary, Matthias Street 11. And the only inconvenience is we have to manually put 3-letter abbreviation of the country. For Hungary it is HUN, and the month of update because it is used in the file name. Okay. Next we will use geocode methods of OpenStreetMaps to get coordinates of this address as latitude and longitude. And what we'll do next, we'll try to get coordinates of 1 kilometer range. As you know, 1 kilometer is roughly 30 seconds, 30 arcseconds. And you know, we have degrees, minutes and seconds. 1 degree is 60 minutes, 1 minute is 60 seconds. So if we try to turn 1 arcsecond into degrees, to decimal values, we have to divide it by 30, or by 60 and by 60 again. So 30 arcseconds, to convert it to decimal values, is 30 divided by 3600. Okay. And finally we plot our area, 1 kilometer area. Our geopoint, our Matthias Street 11, is somewhere here in the center, and it is 1 kilometer range in center of Budapest, Hungary. And finally what we do next is we'll have to download HRSL dataset for Hungary. It will be a CSV file. And there is a most recent URL of this Amazon Web Services S3 storage. If you follow this link, you will get to XML descriptor, where you can look for these 3-letter abbreviations and names of files and what is their month of update. And we add to this name of the file, just given to it country abbreviation and month of update. And finally we use requests to download the stream from this URL and write it to CSV file here in our storage, and we read from the CSV to pandas data frame and print out 5 lines from the beginning. So this will be the name of the file, and here we have the Hungary CSV. It is 150 megabytes, but from S3 storage to Colab it is lightning quick. Download is very fast. So the structure of this dataset is latitude, longitude and population. So how many people? 1.7 people live in this 30 by 30 meters box, okay? And finally we sum all the people from population column from all the lines that fall under those 4 conditions. So this is in 1 kilometer range, all people from all over here. Let's run. You see, 22,791 person live there, and 1/2 of someone's body is entering this area. Okay, so you see, it is very simple, it is lightning quick, and the only thing is HRSL is covering not 100% of the countries worldwide, but I hope that you will manage to apply this technology to the place where you live. And please keep in mind that HRSL storage address is changing from time to time, and data structure may change, so you may need to update those absolute paths we used. This is some little inconvenience. And thanks to Nick Jones, whose publication in the Words Data Science inspired me to do this post. It's a beautiful, wonderful, fantastic technology. Okay, so thanks for watching, thanks for being with me. Subscribe to the channel, subscribe to www.simpleai.net. See you, bye.